Hello everyone. Let us now discuss LeetCode question number 1639. Number of ways to form a target string given a dictionary. So, the question simply gave with words which have word and the target is given. Target is containing a word. So, we need to construct this target by taking these words, taking a character from word, but we cannot take the character at an index which is less than the character which is took already. I'll simplify it for you. If you take this character, let's suppose I took this b. Let for suppose I took this b. That means if I took this b, then I cannot take the character at here or at at here. That means I cannot take these two characters from this. That means they gave us an intuition that you need to go forward. You need to go forward. That means if I took any character at 0, then I can't take the character which is at the index 0. So it is as simple as that. If I take any character at an index, then I cannot take the character which is at the index below the character taken at previous index. So I think you got the condition. Now you have the 0. You have the 0 at index 0, you have A. Now come to this column. You have 1A, 1B and 1C. So you need 1A here. You need A here. So I am taking that A. Take that A. I am taking that A. Now I want to store what is the next character that I need. The next character that I need is B. But instead of storing the character, I'll be storing the index. So if I want any character, next character, it will directly come to this index. So I'll be storing 1. That means I have got the index 0th character in the target. I need the next character, that is 1. But where do we got this? Where do we got this from? Initially, it is from an empty string. It is from an empty string. The first character that I need, I said that I'll be storing it. So the target index is 0. So I'll be coming from that. So that's it. This is the first possible way. But wait a second. You need one A, right? You got to 0 and took that A. And go to B and then A, go to B and then A, or here and here, then you will get A, B, A. So let me write it. A, B, A. One possibility, A, B, A. Second possibility, A, B, A. Third possibility, A, B, A. Fourth possibility. But we have 6 as the output here. But what we are missing there? That means if you consider this example, we are missing this A. This A. We need to take this A too. That's why let me skip this index. Let me skip the character at this index. So it will eventually become a recursion tree. This is how you approach to the first recursion. Now you have not took anything, so it will be empty. And do we need next character when you doesn't have anything in your string? No, right? It will be 0. So you still need the zeroth character A. So this will be stored in the next as a child. So you got an A and the next character that you need is 1. But how we are going through this? Let me write that too. So initially I will be 0. Initially I will be 0 at here, and then I will become 1. I will become 1 here. I is 1 here. That means we are going through this by I and we are going through this by J. Let me write it down. Sorry. Let me write it down. We are going through I here. We are going through I at here, and we are going through J. We are going through J here. So we are going through I for words and J for the target. As I said, you need zeroth index in from a character from the target and first index character from the target. So this is how you approach this problem. But wait, now you need I uh, j is equal to 1. That means you need b. So you are at I is equal to 1. That means at index 1. Let me circle out. So these are the characters that are available at index 1. I is equal to 1. Now, what are the possibilities? You need the first character, the character at 1 from the target. Listen carefully. You need B. So how many B's are there here? Only one. So take that. Take that B into consideration. Now you have A, B. You are pushing that back into our string. Now what is the next character that you need? That is 2. That means 1 plus 1, it will be 2. So I am taking that B. But what if I do not take that B? Same as here. What if I didn't took that B? Then it will be same. It will be itself A comma 1. So when you, as I said, when you doesn't get this A, why you need the next character? That means you need B, right? You still need B when you doesn't append the B from the back of the current string. So now you need, here you need uh, A here, but the character, yes, we have A here. Now you can append that A or leave it. So append that A. Now you got A comma 1. You will be getting, so you will be getting A comma 0 plus 1 will be 1. Now you need the next character, that is B, for this string. So what if I didn't took? What if I didn't took? So it will be the same empty string comma 0. You still need the first character. So wait. So here it is I is equal to 1, this row. Now I will be 2 here. I will be 2. For 2, check this. I am checking for 2. So you need A for this node. You need A. Do we have any A in the current column? No, we doesn't have. So we will not take anything from the column of word. So you doesn't take anything. You doesn't take anything. Now it will be same as it is. It will be same. Now you need a B here. See, the next character target character is B, so you need a B. So you have a B here, so you can append, or you you doesn't do that. You do it or you doesn't do it. No. What if you do it? A comma B. It will be A comma B, and the next character will be 2. But if you didn't append it, it will be A comma 1 itself. The same thing for this thing too. So the same thing here. Here it will be the same thing. Now if you append that, it will become AB comma 2. It will become AB comma 2. So I think it is time taking, and you can skip if you doesn't need this recursion tree. If you understood this recursion tree, now you need A here. So here it is index 0, a target of 0, you have A, but you doesn't have any A in this column, so it will be same as it is. It will be same as it is. It will be empty string comma 0 itself. So this is the recursion tree at I is equal to 2. Now I is equal to 3. This is the last step. This is where you get the solution. Now you got A, B, and as I said, I is 3. Now you need 2. The character at index 2 in target is A. So how many A's are present? This is crucial part. The target characters that you need is A, and we got 2 A's here. So you need 2 children. So you need 2 children. Then it will be becoming A B A comma 3. It will become A B A comma 3. Same for the next A. So this is the for the first A, and this is for the second A. So let me write it. This is for the first A, and this is for the second A. So now what if I didn't took that? So there is a case that I didn't took that. So if I didn't took, it will be the same AB comma 2. But I think it's unnecessary to do that, as it become 3. That means J value is out of bounds, then no need of drawing that. So AB comma 2 here and AB comma 2 here. The same thing will be continued. The same thing will be continued for this one and for this one. You'll be getting two things, ABA comma 3 and ABA comma 3 for 2 times here, for 2 times. So how many times did you get ABA, our target? It is 6 times. You will not get if you go through this one. You can do that. You can iterate, or you can go for a dry run, but you will not get. So the number of times you got our target is 1, 2, 3, 4, 5, and 6. So if you write a recursive code for this one, as I said, this is I and this is J. Call for a recursion. Call for recursion. So call for recursion. Let me change the font color. Call for the recursion. Now, what am I sending through these recursions? If you see, you need all these words, you need all the number of characters that it comes to the target character. So you need all these words. So send that words initially. So sending that words, and you need this target for the base case that if you got the target, or if you are incremented the j to the out of bounds of this target, so send that target. So we have sent successfully the words and the target, but what are we missing here? Here we have j, here we have j, here we have j, so we should not forget j. And here I is equal to 1 2 3, this is for words and this is for the target. So now I'll be sending I comma j, but what will be coming uh, to the body? So what will be there in here? If you got I out of bounds or j out of bounds, then you will be returning. But before return, please remember that you will be storing the number of you will be returning one here. Sorry, you'll be returning, I think, instead of returning one, you can simply count the number of ways. That means if you go out of bounds, even if you go out of bounds, you will be returning, and before that check if target is reached. If it is reached, then increment the count. So if the target is reached and you got out of bound, then you can increment the count. So you got there. Now, as I said, you need to count the number of A's here. That means you will be iterating these words. So the second thing that we're gonna do is iterate, iterate the words, and the target character is target of j, as you know. And if you got then call for recursion. But what are we doing here? You got a here and you incremented this j and also I. So I plus 1 and j plus 1 will be here. So words, comma target, comma I plus 1, comma j plus 1. Now, after iteration, you got through all these characters. But what if I didn't took? Then what is the condition that j is not incrementing? If you see clearly, j is not incrementing if I didn't take any character. So I am not taking any character, then recursion for words and target simply I plus 1, but j will be same itself. So this is how you write this recursion code. This is the algorithm. This is the simple algorithm for this recursion code. Even though it doesn't run, it will give you time limit error. But we'll be doing one thing. We will construct the memoization code. So if you ask me what is this memoization, let me give you one thing. So I will be increasing this 1 minute. Sorry for the interruption. So what is this memoization? Let me explain you. If you doesn't know this memoization, so let me explain you about this. Here you are going to this a, you are going to this a, this is at this, you know, this is at this sorry, at here and here. So you are coming to this a for twice, but If you see here, for one time, for second time, and for third time, for the fourth, fifth, and sixth. That means you are coming for, you know, three times. You are coming for three times to the same indices. What if I have stored this thing, for this body, sorry, this node you are coming for two times. What if I store this? What if I store, if I had a memory that AB will be coming for two times, and in the next time you simply count A, then the target, as the target character is A, then you will simply return 2 into here, 2 into 2, sorry, 2, then you will be getting here 2, and then for 2 you will be getting here 2, and 2 plus 2 plus 2 you will be returning 6 directly. If you have memoized, if you have memoized, that means you have a memory that this AB is coming for two times. So what I'll do is I will construct a DB, sorry, a DB which stores ij. Now this DB will store, simply this DB will store at I, it will be storing. So as I said, this I will be storing the index of words. So write that I will be storing, I'll be writing that I will be storing, I will store the word index. J will store the target index. So it will be easier to find out the number of ways to get the target index. That means by taking I0, and for example, it you got it 0 and 0, dp of 0 0, that means I is 0 and j is 0. That means how many ways you can get this A by taking this 0? So it is only 1. You can only take 1 here. So this will eventually make our recursion. So this will, I think it is the better approach than constructing the recursion tree, going through this recursion. So firstly, as I said, you will be constructing this recursion tree dp of some length, and you can see the code here, vector of tp. Now here, as I said, initially if initially it will be -1, initially it will be -1, and I will be calling for this same code, recursion code, but instead I will be using the memoization. Now I is equal to what slot size, this is the base case, and then here here as I said, I plus 1 j plus 1. This is the same code as the recursion code. If you see clearly, words target I plus 1 j plus 1, I am calling for the recursion with the same thing, but I am checking words of idx. It is the same thing, that word of uh, idx is equal to target of j. It is the same thing which we are doing there. So dp of ij will store the number of ways to get at index I the target jth index. So I think you got this intuition to change the recursion code directly to the memoization. It is quite simple, and if you need the better approach, that means the optimized approach of TP, then please comment below. I'll be sharing the video. So If you like this video and if you have any queries or if you have any suggestions, then you can please comment in the comment section. Like, share, and subscribe. Thank you.